If this came up on your A-level exam, would you know what to do? How can we integrate sine to the power of 5x? Well, we can integrate this using a substitution, but it's not always obvious what the substitution should be. You might be thinking, well, can we say something like u equals sine x? Well, if we were to make that substitution, we'd need to differentiate sine x, and that would give us cos x. But there's no cos x in the question here. So instead of choosing the substitution to be sine x, let's think of a substitution that will differentiate to give us something involving sine x. Can you think of one? How about u equals cos x? Because if you differentiate cos x, you get minus sine x. So we can rearrange this to make dx the subject, and we'll end up with this. So if I replace the dx in the integral here by what I've got here, then I end up with this. And notice what happens. We have sine to the power of 5 divided by sine. That's going to give us sine to the power of 4. But we still need to connect this back to cos x. How can we do that? Well, you should know an identity. Sine squared plus cos squared equals 1. But that involves squares, not powers of 4. How can we relate powers of 4 to squares? Well, you can square sine squared to get sine to the power of 4. Notice I just put the minus sign on the outside, by the way. You're allowed to do that. Now we can make use of that identity. Sine squared plus cos squared equals 1. So therefore, sine squared is 1 minus cos squared. So we can put that in the brackets. And how can we relate cos squared back to u? Well, it's going to be u squared. So this is going to be 1 minus u squared inside the bracket there. And then we can expand the brackets. We can actually square all of this stuff to get this. And then if we apply the minus sign to everything, just to tidy it up a little bit, we'll end up with this. And now this is ready to integrate. And we can integrate it in the usual way. Just don't forget your constant of integration, your plus c. And also don't forget that the original question asked us to integrate something involving x. So we need to convert our u's back to x's using what we started with, u equals cos x. So we replace each of those u's with cos x, and we end up with this as our final answer.